There are many types of actions we can react to in our applications. Welcome back to Rxjs and Angular Reactive Development from Pluralsight. My name is Deborah Karata, and in this module, we look at more examples of reacting to actions. We may have a user interface design that displays a list and allows the user to select an item to view its detail, or we may provide an option for the user to add a new item. We need our application to react to the user's actions and adjust the displayed data. In this module, we extend what we've learned to react to selections and display a detail page. We examine how to react to errors and display error messages using a stream. And we walk through how to react to add operations and display the newly added item in a list. The Rxjs features covered in this module include merge and scan. Let's get started.
Looking at the previous code, this means instead of the first example, we do this. Instead of the second.
In this style of user interface, we have a list on the left. The user clicks on an item to see the detail on the right. We use two components, a product list component on the left and a product detail component on the right. Can we leverage the techniques we just learned to communicate actions across components? Yes, we can. Let's take a look. We are back in VS Code with the APM project open. Before we begin, let's take a quick look at the product list alternate UI. Notice that the list displays the product category IDs, not the strings, and clicking on a product does not yet display the detail. Going back to the code, this alternate user interface is defined in the product-list-alt folder. Here in the product list alt component, we defined the product's $observable earlier in this course. Let's change it to use the products with category observable, so we have the category IDs mapped to the category strings. Then in the product list alternate UI template, we change the template to bind to the category name. Looking at the browser, we see the category strings displayed. Now let's implement the selection to display the detail. Back in the code, let's look at the product detail component. It looks a little empty in here. The detail page should bind to a single product. In the product service, we only have an observable that emits the array of products. How do we get a single product? One option is to issue another HTTP GET request for a single product. But if we already have the products loaded, why bother going back to the server? Let's instead define another stream here in the service that returns a single product from our existing observable. I'll paste the code and we can talk through it. I called the observable selected product $. Because we want the product detail to display the category string, we start with the products with category $, observable. Then we map the array of products. We use the array find method to find the product with the selected product ID. Since we don't have the action stream at this point, let's hard code an ID of 5. I added tab for debugging. Going back to the product detail component, we declare a product $, stream and assign it to the stream we just created in the product service. I'll use the quick fix to add the needed import. And notice that I included exception handling. Hovering over product $, we see that it's an observable that emits a product. And now that we're planning on binding to an observable, we can change to the on-push change detection strategy. We define the strategy in the component decorator and add the needed import. Since we no longer need it, we can delete the product property. Looking at the product detail template, we bind to the product $, stream using an async pipe. We use the as clause to emit the value into a variable we can use throughout the template. Checking it out in the browser, we see the detail for our hard-coded product. Yay! Next, let's implement the selection action. When the user selects a product, both the product list alt and the product detail components must react. We'll style the product in the list on the left to more clearly show it was selected, and display the detail for the item on the right. In this demo, we react to the select action and display the selected product's detail. Remember our steps for reacting to actions? First, we create an action stream. Do we create it here in the product list alt component? Since both the product list alt and product detail components react to the selection, we'll define the action in our service. In the product service, let's declare a behavior subject and use the quick fix to add the import. We use a behavior subject here and not a subject to ensure our action stream emits at least once. The action stream will emit the ID of the user-selected product, so we define a behavior subject of number. We mark the subject as private so only the service can access it. Then we expose the subject's observable using asObservable. The second step for reacting to actions is to combine the action stream with our data stream. Let's use combine latest again. We want the pipeline to re-execute when a product is selected, so we combine the products with category data stream, so we get the category names, with our product selected action stream, so it reacts when a product is selected. I'll paste the pipeline code and we can talk through it. First, we use array destructuring. Our first input observable emits the array of products, and the second emits the selected product ID. We then use the products array find method to find the product in the list that matches the selected product ID. The last step for reacting to actions is to emit a value to the action stream every time the action occurs. For our example, we want to emit the selected product ID every time the user clicks a product on the product list alt component. Looking at the template, we already have a click event bound to an onSelected method and pass the selected product ID to that method. In the component, we have the onSelected method with a parameter for the selected product ID. Do we emit the value to the action stream here? Since the action stream is defined in the product service, let's define a method there that emits a value to the action stream. We'll name the method selectedProductChanged. It takes in the selected product's ID and calls the subject's next method to emit that ID to the action stream. That causes our combine latest to emit, and our pipeline is re-executed. Back in the product list alt component, whenever the user selects a new product from the list, we call selectedProductChanged, passing in the selected product ID. In the product list alt template, we bound the product's $observable to display the list of products. But our template also needs notification when the selected product changes, so it can highlight the appropriate entry. Back in the component, we define a selected product stream and set it to the selected product from the product service. Now we have one stream of all products and another stream that emits the selected product each time it changes. We can then modify our template to use this observable. We change the ng class to use the async pipe. Notice the syntax here. We use the async pipe to obtain the emitted product, then access the product's ID. Be sure to include the safe navigation operator, the question mark, because when the page is first displayed, there is no selected product. Going back to the component, we can delete the selected product ID since we are using the selected product observable instead. And now that we're binding to observables, we can change to the onPush change detection strategy. We define the strategy in the component decorator and add the needed import. Let's try it out. In the browser, select a product, and it displays in the detail page. Select another product, and it displays, and the styling highlights the selected product. It works! Yay! We're reacting to the selection action in both of these components. Looking again at the service, we've defined a subject for our action stream and a method that emits values into that stream. Any code in the application can call this method to emit a value. Let's think about that a moment. That means that from anywhere in the application, we can call this method, emit a new selected product ID to the stream, and the application reacts appropriately, updating the display. No more managing flags or manually handling state changes. But we do have an issue. Looking at the product list alt component, we've just changed another component to use onPush change detection. Yet we are setting an error message property that now won't trigger change detection, so it won't display in the UI. Let's fix that. In this demo, we react to error actions and examine how to display error messages using an observable stream. We are looking at the product list alt component. Recall from earlier in this course that Angular's onPush change detection only detects changes made to input properties and events from child components and observables bound in the template using an async pipe. Bound values set in local properties won't trigger change detection, so won't update the UI. Notice our error message property here and here. Updating this property won't trigger change detection, and the error message won't appear to the user. We saw this issue earlier in this course, but let's take a look again. In the product service, we change the URL to an invalid value. I'll delete the S, then bring up the browser. Open the developer tools and click on Product List Alternate UI. The error does not display in the UI, but it does appear in the console. Looking back at the product list alt component, let's change the error message string property to an action stream. Any guess as to how? Yep, we create a subject and use the quick fix to add the import. Then we expose the associated observable using asObservable. We see a syntax error here. How do we set a value into a subject stream? We call the next method on the subject, passing in the value to emit to the stream. With the observable stream in place, we update the template to bind to the observable using the async pipe. We use the as clause to emit the value to a variable that we use here. Checking it out in the browser, click Product List Alternate UI, and we now see our error message in the UI. Yay! The message could use some improvement, but we are seeing the message. If you're coding along, make this same change in every component that displays an error message. And let's not forget to change our URL back to a valid value. Next, let's look at how to react to an add operation. Our applications often provide features for creating new items, such as a new product. Our sample application doesn't have edit forms. This screenshot is from my Angular Reactive Forms course. But even though we don't have the UI in place, for our purposes, we'll add a hard-coded product when the user clicks this button. In more real-world scenarios, you can leverage the techniques we'll use to add the new product. Before we jump in, let's introduce two additional Rxjs features. Merge combines multiple streams by merging their emissions. Here we combine 3 streams and create one stream with values from all of the combined streams. Merge is a static creation function, not a pipeable operator. Merge is often used when combining sequences of similar types to blend their emitted values into one output stream. Looking at the marble diagram, in this example we merge 2 streams. As each item is emitted from either stream, the item is emitted to the output stream, resulting in a single stream of all values. More formally, merge is a combination creation function. It takes in a set of observable streams as an input, subscribes to each, and creates an output stream. When an item is emitted from any of the input streams, it's emitted to the output stream. It completes when all input streams complete. Scan accumulates items in a stream using a provided function. Here we specify an accumulator and a current value, adding the current value to the accumulated sum. Scan is used for totaling amounts or other accumulated values, and accumulating items into an array. Looking at the marble diagram, in this example we accumulate a total amount. 2 is emitted and used as the initial value for the accumulator. 5 is emitted, added to the accumulated 2 to produce 7, and 9 is emitted, added to the accumulated 7 to produce 16. More formally, scan is a transformation operator. It takes an observable stream as an input, subscribes to it, and creates an output stream. When an item is emitted from the input stream, the item is accumulated as specified by a provided accumulator function, and the intermediate result is emitted to the output stream. Merge and scan work well together to react to an add action. We have a data stream of products and an action stream providing notification when a new product is added. The action stream emits the new product. First, we merge our data stream and our action stream, flattening the data to a single stream. The output stream contains our product array and our new product. Then we scan to accumulate the new product into the product array. The first emitted item, which is the product array in this example, is used as the initial value for the accumulator. When the new item emits, it's accumulated as defined by the accumulator function. In this accumulator function, we define a new array and use the array spread syntax to copy the original array elements into that new array. We then add the new item from our action stream to that array. The result is a new array with all of our original items, plus our newly added item. Any views bound to this observable automatically update to show the new item. Let's try this out. In this demo, we react to an add operation and display the added item in the list. As we've seen throughout this course, a data stream often emits an array of items, and we bind to that stream to display those items in the view. When a user adds a new item, we react to the add operation by emitting a new array. That new array contains the elements from the original array and the new item. Emitting a new array triggers change detection, and the list is redisplayed with the newly added item. To allow adding items from any component, let's define our add action in the product service. We again follow our 3 steps for reacting to actions. First, we create an action stream. In the product service, we declare a subject and add the associated import. Since we want to emit a new product into the stream, we define a subject of product. We mark the subject as private so only the service can access the subject. We expose the subject's observable using asObservable. Now that we have our action stream, the next step is to combine the action stream with our data stream. Let's declare a new observable. I'll call it products with add $. In this case, we use the merge creation function to merge our data stream and our action stream and add the import for merge. Be sure to select the creation function from Rxjs and not the operator. We'll use the products with category $, data stream to display the category name instead of the ID and the product inserted action $, stream. The merge creation function emits the elements from both streams into one output stream, so the resulting stream emits both product and product array items. We pipe the result through the scan operator and add the associated import. The scan takes in the accumulator, which is of type product array, and the current value, which is a product. We define the accumulator function to create a new array, copying the array elements from the original array into that new array using the array spread operator. Then we add the item from our action stream. The result is a new array of products, including our original product elements and the new product emitted by the action stream. In the product list component, we modify the products $ stream to use our new products with add $, stream. Since our products with add $, stream merged the new product with the products with category stream, we'll get our category names. Our last step for reacting to actions is to emit a value to the action stream every time an action occurs. In our example, the action occurs when the user clicks the Add Product button. In a more real-world application, that may happen when the user clicks to save a newly created product. The click event of the Add Product button is bound to an onAdd method in the component. Looking at the product list component, we don't emit the value to the action stream here. Since the action stream is defined in the product service, we'll define a method there that emits a value to the action stream. I'll paste the code and we'll talk through it. In a real-world application, we'd pass in the new product from the edit operation. But to try this out, we can instead use a fake new product that I defined here. I use the OR operator to set the new product variable to the passed-in product, or if the passed-in product is undefined or null, to the fake product. We then call the next method on the action stream to emit that new product. Back in the product list component, we delete the log statement and call the add product method from the onAdd method. We don't pass in a new product. We'll let the add product method use the fake product instead. Let's check it out in the browser. Click Product List, then click the Add Product button. The new product is added to the bottom of the list. Clicking again adds another one. Yay! We've successfully combined a data stream with an action stream and emitted a new product to the stream to react to an add operation. The item automatically then appears in the list. Let's finish up this module with a brief summary and checklist for using the features we've covered. This module was all about reacting to actions. When reacting to actions, we follow 3 steps. Create an action stream, often using a subject or behavior subject, and expose its observable. Combine the action stream with the data stream so the data stream can react to the action. Lastly, emit a value to the action stream when an action occurs. We followed those steps to react to a selection, selecting an item to view its details. We created an action stream using a behavior subject, so our action stream would immediately emit a default value. We combined our data stream with our action stream, and we emitted a value to the stream each time an item was selected. We reacted to the selection in 2 different components, the product list all component to highlight the selected item, and the product detail component to display the selected item, demonstrating that we can use these techniques for component communication. We reacted to errors by displaying an error message. We created an action stream using a subject. We don't want a default error. We skipped the stream combine step because we didn't need our data streams to react to an error action. We emitted a value to the action stream each time an error occurred. In this module, we covered several Rxjs features. Merge merges the emission of multiple streams into a single stream, and scan applies an accumulator function. We saw that merge and scan work well together when reacting to an add operation. You can use a similar approach for edit operations, creating a new array and replacing the edited item in that array instead of adding a new item. Next up, let's look at caching our streams.